Okay, as always, these assignments have two components. One is setting up your VREP environment, and the other is setting up the Python script. So let's first do the VREP environment itself. So what you need to do is, on a blank environment, go to Add, go to Path, and click on Segment Type. So you can see that a path has been created, a single straight line path. So we would want to give this more complexity. So when path is highlighted, go to this icon right here, the toggle path edit mode. Click on that. All right, zoom out a bit. And then you can see that there are two paths here, the path points, 1 and 2. So on 2, right click and select insert new control point after selection. All right. So once path 3.3 has been highlighted, just move it to wherever you desire. Now I move it here, close this. All right. So now we have a left turn, a gentle left turn. Let's add a simple right turn. And then move it as well. Close this. All right. So I've added 4 points here, 1, 2, 3, and 4. So if you wish to make like a complete circle or something, you can click on this option right here. Path is closed, so that I'm going to leave that up to you. But as far as we're concerned for this demo, this should be good enough. Click on yes. All right. So let me save this before. Okay. All right. So now we've sort of defined our path, but we need to do something to, have like a black line right here, like what I showed you right here, and have like a thick black line rather, so that the IR sensor can pick up. And to do that, just double click on this, show path shaping dialog, and click on this option. Once you do that, click on adjust color, click on ambient or diffuse component, and make this line black by setting its RGB values as all 0. All right, and then in type, choose horizontal segment and increase the thickness. I found that a scaling factor of 1.5 is good enough. If you want, you can make it thicker, but yeah, this should work. All right. Now let's add the robot. So we'll be using a slightly different robot because this particular robot already has its vision sensors lying face down. So that saves us some time. But if you want, you can always choose that Pioneer robot and you can add its own vision sensor. You can check the documentation for the differences between these two types. But yeah, I'm going to leave that up to you. Even on this robot, if you wish to add more sensors, this is the same way that you have to do. Select this robot, right click, go to add, and vision sensor. Yeah. So this is also a differential drive robot because this has 2 wheels, and this comes in inbuilt with 3 vision sensors. So let's expand this. Yeah, you can see right here. You have a left sensor, a middle sensor, and a right sensor. And for the purposes of this demo, or whenever you're making your solution, just ensure that the line touches one of these sensors or yeah, it doesn't matter. Just make sure that when you place your robot, it is in the track itself. Okay, so and there is one thing that you have to do. You have to disable its script. So this is a script that. Okay, yeah. So will it be able to detect short lines? It can detect sharp lines, but the question is, can the robot turn at a sharp angle? And for that, it's up to you to experiment with it. I don't think it'll work. Uh, I don't think the robot will be able to perfectly turn like a perfect 90 degrees. So it would be a nice idea to introduce a sort of gentle curve. But yeah, you can play around with it. Uh, as far as the sensors are concerned, yes, it should be able to detect. But the question is whether or not the robot can rotate. So yeah, so this is a script that comes inbuilt with this robot, and we want to disable it because we want to write our own script. So go to Tools, Scripts, choose this line tracer, which is the name for this robot, and have it disabled. Okay. And that is basically it as far as the VREP environment is concerned, setting it up. Now let's go to the Python script. So this script is slightly longer, but it's very simple. Uh, you basically know these steps, so I'm not going to repeat it. So we have to copy this line right here. Okay, so that's basically all this portion. Uh, so now it's a good time to start making definitions, your own functions. So I made 4 functions. One is to basically move the robot straight, make a left turn, make a right turn, and read sensor values. So this is something that you guys should know from your kinematics lesson on how to make a robot move straight, take a left turn, or take a right turn. Uh, Now, getting sensor values is also something that we explored in last week's session. So these 3 lines, okay, let me open this up. So this is the function that I'm calling to read the vision sensor. So last week we read a proximity sensor, but that will not be good for getting a line following robot. So we need to use a vision sensor. So that's the function that I'm invoking here. And all of these arguments can be basically seen here itself. All these parameters, client ID, sensor handle, operation mode, they're basically the same thing that I've added here. I'll explain this portion in a little bit. They're basically to tell you the intensities that each of these 3 sensors reads. So for example, this line right here gives me the intensity given by this sensor, and the other 2 lines give the intensity given by these 2 sensors. So you will see that when you do your own implementation, and when you have like a setup similar to this, in this exact scenario, the readings given by your left and your right sensor will be much higher than that given by the middle sensor, because this is a light surface and this is a dark surface. So for example, in this case, this will give something like say 0.02, and this will give something like 0.7, and this will give something like 0.75. So I'm just retrieving these values and storing them in variables. Yeah, so that's as far as the user-defined functions are concerned, now it's also just boilerplate code. You define like a velocity in which you want your robot to move. You get your object handles for the motors, your two motors, and these are the names: dynamic left joint. You can see the name right here. Dynamic left joint. Yeah. This one and this one. So that's the same name I've given here. And then you have to get your object handles for your three sensors: left sensor, middle sensor, right sensor. Left sensor, middle sensor, and right sensor. All right. And now, so if you go to this script right here, sorry, this documentation, whenever you're dealing with sensors in VREP, you have to call this function twice: once to initialize it, and the other to start being able to record values from it. So you can see right here, recommended operation modes for this function are OP streaming for the first call and buffer for the following calls. So the first time you call this function, you should have this option invoked. And that's what I've done here. Okay, so Aditya asks what are meant by handles. So handles are nothing but variables. Okay, so for example, you want to have a variable that is associated with the left joint. So that is what is meant by a handle in terms of VREP. It is nothing but a variable to associate with a particular portion of the environment. So this handle right here is like a variable for the left joint. That's all you basically need to know. Yeah, does that answer your question? Okay. So yeah, as I was saying, you need to call your vision sensors twice. Once to initialize them with the streaming option, and the other is using the buffer option. So the first time you invoke this function is right here. And because of that, I have the streaming option. And you need to do that for the left, middle, and right sensors. So you can also see what output this gives. This gives a return code, detection state, and aux packets. So this is the thing that we are concerned with, all right? So it says that it returns like an array of 15 values. And the values that we are particularly interested in is the average intensity right here. So I'll tell you how to retrieve this particular thing. It's nothing but this command right here, but I'll show you why it's like this in a bit. All right, so now we have our user-defined functions, which we will call later on. So when you first run this code, these won't get called initially because you've not called these functions, you just define them. So first, this step will get executed, then it'll go here. All right, and then once you call your vision sensor the first time, yeah, it's right here. So Alan asks, what is the speed of the motors? So I defined it right here. You can define different speeds for the left and right wheel, but I've defined them as a single speed. So whenever it's moving straight, whenever the robot is moving straight, it's moving at a rate of 0.3. I think this is meters per second. I'm not too sure the unit. Now I've divided, when I'm taking left or right, I just divided it by 2. There's no need to do this, but I just wanted to make sure that it turns smoothly. You can play around with these values as well. You can even give the robots different wheel velocities when they're turning, but don't give them different wheel velocities when you want them to move straight. That's all you need to know. Okay, so let's go ahead and at least start something. Ooh, okay. So this is this is the first portion of the script that just sets up the environment, gets the object handles, ensures that the sensors can start recording. And this second portion of the code is the actual on and off controller. I suppose I'll explain it right here as well. So get sensor values is my own function that I've defined right here. You need to call this each time before you make a decision. So if you recall right here, you can see that we first have to sense, and based on the sensed values, we have to take a decision. In this case, our decision would be to either take left or right. So that depends on the latest available sensor readings. So you have to keep calling this function that I've defined each time before you decide to either turn left or right. So let's set up a loop right here. And under normal circumstances, you would want to move straight because it's sort of like this, right? Under the default circumstances, you would want to move straight because there's no need to turn left or right. So you move straight, then you get your sensor values, all right? And then based on your sensor values, this is a simple condition that you have to check on which sensor gives you the most intensity. Based on that, you have to either turn left or turn right. So it's based on this simple diagram right here. This uses one sensor, but this particular script relies on just 3 sensors. The logic is the same. You have to compare with all 3 sensors and see which one is indicating the maximum or the minimum. And then, yeah, that's basically it. I'll show you like one demo so that you understand what's happening. And this script basically needs to be run in like 2 separate stages. This is the first half that I'll run right now. But before that, let's run this. Okay. All right, so this entire block of code has been run and there are no complaints so far. Let's just uncomment this section out. Okay, so remember that I told you that I'll talk about why these things look like the way they are. So that's because of this particular thing. So in Python, if you have something located in a, like if you have variables in a square bracket, it's called a list, okay? Now this is a list inside a list because there are 2 square brackets. And we need to get the 11th reading from this. Why 11th? It's because of this right here. So read vision sensor, we need to get the average intensity. I'd like to rely on the average value rather than a maximum or the minimum. So this gives this function right here, this aux packets function variable. It contains 15 variables in 15 values inside that variable. So and we need to access the 11th. That is 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, 11. And Python starts its array counting at 0. So it's not, so it becomes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's how this number 10 comes up. And this first 0 right here is because it's a list inside a list. So this first 0, it accesses the inner, it enables Python to access the inner list. And the 10th number here means it access the 11th value in this list. Okay, so now let's see if this works out. You can see it sort of does something, then it sort of trails off. That can be fixed by, making the robot slower or something, or will it correct itself? It does, but yeah. So that's sort of the limitation of your on and off controller. It was working slightly better when I was testing it out yesterday, but yeah, that's just a limitation of your on and off controller. It does go back, but yeah, that's maybe that can be mitigated by having like a thicker line or a thinner line. It's up to you to play around with it. I just wanted to show you a small demo, but yeah, it does sort of work. All right, and that's basically it. Let's see if it turns this right turn, and then we'll stop the simulation. Okay, yeah. Suppose that should be enough. Yeah, so you can see that maybe having a PID controller would not have caused that small drift that you saw here. But yeah, that's up to you to perfect. Yeah, so Aditya is right. If you use a PID controller, that should correct its errors much quickly than an on and off controller. So you can see that it sort of had to go out of its way and then correct itself, right? That would not happen if you design like a proper PID controller, but just to get started, you should try with your on and off controller first so that you know what's going on. And that's essentially it, yeah. So I'll share parts of this code at least up till here. I'll also share some instructions on how to set up the VREP environment.
Thank you for this fourth session.